Hello everyone, I'm Ahana Ganguly and this is our presentation for the Fluid Mechanics course. We are having a team code of 15 and the topic which we have chosen is oceanic flows. So, before proceeding into the presentation, let me introduce you all to my team members. As you can see, these are my team members. The first one is obviously me, Ahana Ganguly, and I'm a student of the mechanical department. The next one is Alamkrita Roy, who is a student of the agricultural department. The third one is Ruchi Dubey from mechanical department again. The fourth one is Bhavya Sharma from the mechanical department. And the fifth one is Harishwar Aditya from the naval department. So, let me show you what are the problem statements which we have chosen and we tried to explore. So, as you can see, we have chosen two different kinds of problem statements, which are a bit different from each other. But yeah, both are very important. So the first one is that, how do background currents affect tides? And the next one is that, how do waves and tidal currents provide energy and how can they be used? If you think with a scientific approach, you can say that the first one is obviously more important than the second one. But yeah, if we think about daily life usage or a common man's life, we can say that obviously the second one is much more important than the first one because it deals with the energy part. So, before proceeding into the presentation, I would like to give a brief introduction about what exactly is a tidal current. So for it, over to the next slide. What is a tidal current? Tidal currents occur in conjunction with the rise and fall of the tide. The vertical motion of the tides near the shore causes the water to move horizontally, creating something which is called as a current. When a tidal current moves towards the land and away from the sea, it is known as a flood, and when it moves towards the sea, away from the land, it is called as an ebb. So, these tidal currents that ebb and flow in opposite directions are called as rectilinear or reversing currents. So basically, we need to understand that tidal currents are the types of attractions or something like that, which is entirely dependent upon the gravitational force of attraction between the earth and the sun or the earth and the moon. So here a very important thing to note is that the gravitational force which is exerted by the moon is much more as compared to that which is exerted by the sun. Now why is it so? Like, the fact is that the mass of sun is much more as compared to that of the moon. So it's like that the sun should exert a greater gravitational force. But this is not happening. Why? This is just because of the distance between the two interacting bodies. As we know, the gravitational force also depends upon the distance between the two interacting bodies. So here we have to see that the distance of the moon is mostly much lesser as compared to that of the sun from the earth. As we can see that the moon is 389 times closer to the earth than the sun. So because of which the gravitational force which is exerted by the moon on the earth is about twice as compared to that which is exerted by the sun. Now, when the moon is at a full or new phase, the tidal current velocities are strong and these are known as the spring currents. When the moon is at first or third quarter phases, the tidal current velocities are weak and are called as neap currents. Now, this is the total introduction of tidal currents. Now we will proceed into what is called a tidal numerical modeling. So, let us see that in the next slide. An introduction to tidal numerical modeling. The tides that we can observe in our seas and oceans are a result of the gravitational forces that exist between the earth, the moon and the sun, as I already said in the previous slide. While the gravity provides the driving force, it is the Earth's rotation, the shape and size of the ocean basins, and the local coastline that ultimately determines the magnitude and frequency of the tide at a particular place. So using a technique called harmonic analysis, we study the different kinds of tides. Now basically we all know that a tide is a mixture of different kinds of simple waves which at times produce a complex wave, and it can be difficult to study if you are studying all of the different kinds of waves together. So basically what we do using harmonic analysis is we simply break up the tide into different simple waves and study each of them separately. So as we know that the harmonic waves have a very specific frequency related to the movements of Earth, Moon, and the Sun. This I was talking about the different kinds of standard harmonic waves which we have. However, the amplitude of each of the harmonic waves and their phases are unique to each location. By combining these harmonics, the tides can be computed for any point forwards or backwards in time, provided the local conditions such as the shape of the coastline has not changed. From here, we can understand that this harmonic analysis is applicable only when the local conditions like the shape of the coastline, etc., these remain constant. Now, let us discuss about the different types of standard harmonic waves which we encounter in our daily lives. So first of all, in this slide, as you can see, the shape of the tidal harmonic. It's a typical mathematical sine wave which we have seen a lot of times. Now let us discuss about the principal tidal harmonics. The first one, as you can see, is M2, which is the principal semi-diurnal lunar harmony. The second one is S2, which is the principal semi-diurnal solar harmony. You can get the properties of all these kinds of tidal harmonics in this slide. Now, N2, L2. These are two semi-diurnal lunar elliptic harmonics. These modulate the amplitude and frequency of M2 for the effect of variation in the moon's orbital speed due to its elliptic orbit. And the final ones are M4 and MS4. These higher frequency harmonics are usually only about 5% of the size of M2. You can get all about the properties of these tidal harmonics in this slide. Now basically the diagram which we can see here is a basic spring-nip cycle which is reproduced by using a combination of M2 and S2. Now, the next part which we tried to explore was all about the mathematical formula and everything about the tidal forces. Now, for it, over to the next slide. Derivation of the tidal force. Now, first of all, let us go through this diagram. There are two masses, M1 and M2, and each of the two masses rotate about one another and under the action of gravity, and they are in a stable binary orbit. This is the center of rotation, as you can see, and R1 is the distance of M1 from the center of rotation, R2 is the distance of M2 from the center of rotation. The force balance is given as follows. Fg equals to Gm1m2 by r square, which is the gravitational force, and m1v1 square by r1 equals to m2v2 square by r2 equals to Fg. This is the centripetal force balancing. Now coming here, m1v1 square by r1 equals to m1 omega square r1, m2 omega square r2 equals to m2v2 square by r2. Now this omega is the angular velocity of rotation. Now cancelling this omega square between these two equations and equating them, you can see that m1r1 equals to m2r2. Now the second one allows us to calculate the center of mass, where the center of rotation lies, knowing the masses. For the case of the Earth and the Moon, we have the following. So basically, as you can see, we have the different values: the mass of the Earth, the mass of the Moon, and the radius, which means the distance between the mass, like the Earth and the Moon. So basically, let us just have a look at this diagram, where r is the radius of the Earth and p is the distance of this particular point from the center of the Earth. Now, as you can see, you can get the force balance per unit mass for particles directly under the other mass but on either side of the Earth using this particle. Now here, as we can see, that in this two formulae, you can see that since r is much smaller as compared to p, as you can see in this diagram, so this r is ignored and this results to pq. So basically this will be like this Fa minus Fc and Fb minus Fc. These are inversely proportional to pq. So let us consider a bit more about this tidal force. Although the Sun has a mass that is larger than Moon by a factor of 2.5 into 10 to the power 7, because the distance between the Earth-Sun is about 400 times than that of the Earth-Moon, the effective tidal forces are larger for the Moon than the Sun by about a factor of 2. I already said this before. Now let us see the effects on tidal force. Now, since you can see, because of this tidal force, the Earth actually bulges. It is no longer a sphere and it bulges into an ellipsoidal kind of shape, as you can see, and you can get the reason for this all about in this slide. Now we just looked upon the first problem statement. Now let us just explore the second problem statement a bit. This is not exactly a problem statement. It is like we need to explore what are the things we can do to increase this energy so that more amount of energy is generated from this ocean waves. Ocean waves are converted to electricity with wave energy converter or WEC devices. Now basically, America is leading at doing this kind of things. With 50% of the US population living within 50 miles of coastlines, America can lead a new energy industry and meet a huge energy demand with reliable and forecastable clean energy. So, this is all about how do tidal currents provide energy and which continent or which countries are leading at it and how can we improve this energy generation. Now, this was all about my part. Now, let me hand this over to Alankrita for explaining her part. Thank you, everyone.
Thank you, Ahana, for giving me this opportunity. My name is Alankrita Roy. My roll number is 20AG30003, and now I will discuss the past researches that took place in this direction. National Oceanic and Atmospheric Administration provided tide tables to predict high and low tides in the US. In the accompanying image, we can clearly see that this is the first ever version of such tide table, which was formed back in 1867, and here it mentions in the month of January and February at what height and at what time the tides will strike. Now, National Oceanic Administration monitor water levels around the nation. Accurate water level data is critical for many coastal activities, from navigation and engineering to restoration and preservation. In addition to water levels, the station measures other oceanographic and meteorological parameters such as water temperature and wind speed. This information is to ensure safe navigation through access to real-time data 24 hours a day, 7 days a week. This model used the data to provide a look into present and future oceanographic conditions, which can enhance tsunami and storm surge warnings. It is also used to publish annual tide predictions. And National Water Level Observation Network is a permanent observing system that includes 210 continuously operating water level stations throughout the US and its territories. Now, this is the second part of a problem statement, that how to harness energy from ocean. Ocean energy could be the wave of the future. If the term renewable energy brings to the mind a sea of solar panels or towering wind turbines, you're not alone. It becomes more and more common to capture energy from sun and wind. That's because these clean energy sources generate electricity without polluting our air. But solar and wind power have one big downfall. They are not always available. The sun only shines during the day, wind comes and goes. There are very few spaces where wind is constant enough to generate electricity all the time. And as easy as it sounds, storing energy for later use has proven a major challenge. But ocean waves, as anyone who stayed near a beach can tell you, waves crash onto shore morning, noon, and night, and that makes them ideal for generating energy around the clock. The first step in this direction is to figure out the best places to put these energy converters. These two researchers are environmental engineers in Australia. These researchers started out with an existing computer model called SWAN, simulating waves near shore. It predicts the strength and location of ocean wave energy. The model helped the team to find hotspots with abundance of wave energy. Each site is within 5 kilometers of shore in water and no more than 22 meters deep. Here we can see that this is what the model predicted. In the red spots, there is the probability for getting maximum energy from the oceans, and this data is being formed from using SWAN, a computer model. And these are the accounts of physics concept which the SWAN simulation uses. And these are the output quantities which this SWAN model gave. Now, wave energy generators come in many shapes, and these are the various shapes in which the wave energy generators could be formed, and one such is discussed here, which is the sea carpet. So, scientists are trying out a lot of different ways to overcome the challenges. So, one such researcher is Mohammad Reza Alam. His team at University of California designed this converter to mimic a muddy sea floor. Places with lot of mud are good at absorbing incoming waves. So the carpet part of this converter is made from a smooth sheet of rubber. It rests near the sea floor where it can bend and flex right along with the waves. As it moves up and down, it pushes past in and out a piston pump. The pump converts the piston's movement into electricity. Now we'll request Aditya to take the charge.
Hello everyone, I am Harishwar Aditya and I'll take on from here. So first up, problems with harvesting tidal energy. As we all know, tidal energy is one of the most cleanest sources of energy, but we have problems as well. So that's the reason we have not developed as much as we wish. So the biggest problem is the cost associated with tidal power plants. So they have turbines, generators and all that stuff are very costly, which makes it highly not very accessible to everyone. Another concern is the environmental effect they have on marine life. So the blades could kill sea animals. They produce noise as well. So the noise is harmful to every sea organism that is highly noise sensitive, and they could also have a risk of oil leakages, which pollutes the water, which could be dangerous to marine life. And the next problem is the location limits of tidal plants. So they generate power from tides and the flow of water. So we need them to be located specifically in places where the tides are bigger and we could get more efficient. We could generate power more easily. So that's a big threat as well. Like, it's not very dependent the amount of tides we get in a places. Next up, the durability concern. So tidal streams, as we know, are like very aggressive and they can really harm any equipment it is. So since water is like 784 times denser than air, water turbines have to be so much stronger than wind turbines. They cannot be as fragile as wind turbines. So that makes the durability hard for water turbines. And of course, the corrosive nature of sea and how that harms the equipments, and yeah, that's also a concern. So solutions to these problems is, there are a lot of solutions which have come up in the recent times, and one of the biggest ones is a coating technology which could prevent the corrosion. So as we all know, stainless steel is an option, but stainless steel cannot be completely reliable. So they've come up with better coating technologies as well. And another breakthrough came up with turbines with no gearboxes. So gearboxes, as we all know, is a very common occurrence in every engineering equipment. So gearboxes, generally they transfer energy through rotation of gears. So when they are used in turbines, as we all know, turbines undergo a lot of turbulence with tides. They can be easily affected. So they take up a lot of maintenance costs and time as well. So when they have come up with no gearboxes, it makes it more accessible and more maintenance free. And as we all know, artificial intelligence is stepping up in every field. So even tidal energies, even in this space, artificial intelligence have come up with some better alternatives. Like they study the data of the tides, and they could alter the design of that to utilize maximum energy from the tides. So such a design could cut down lifetime costs so much. Even a project called Element, led by a Scotland-based innovation company, it was valued around 5 million euros. It commenced on June 2019. So basically, the data is captured and it maximizes the turbine's performance and efficiency by studying that data. So yeah. And a lot of universities and a lot of bigger companies as well are investing in the same thing, like we can see here. And other innovations are, there is a way by Oregon State University. So they are researching currently on direct drive generators which don't require the use of a hydraulic fluid or air. So basically, instead of just relying upon bigger tides and waves, we could generate energy by the turbulence of buoys being deployed in sea. So even that wave and even a small movement could generate electricity, which makes it more efficient. So they do not have to depend more on tides. So so they can be directly generated from ocean movements as well, so which makes it very convenient. Yeah, thank you.
Hello everyone, I'm Ruchi Dubey and now I'm going to discuss about the hydrodynamic analysis of ocean tides. So in the given diagram, there is a simple model of the Earth-Moon system which we are going to consider for writing the equation of tidal of the surface of Earth due to tides. Now in this we are considering the coordinate frames to be the XY rectangular coordinates with origin at the very center, which is the center of mass of Earth-Moon system. We are also making some assumptions, which are that the gravitational force due to Sun is neglected, the spinning of Earth about its own axis is neglected. We are also considering Earth to be perfectly sphered and covered with water. The density of liquid is assumed to be constant. Now we are using basically two equations, which are the continuity equation and the Euler's equation. Now we know that center of mass of Earth rotates with a period of 28 days about the very center. Um, and if we consider the omega of Earth as omega is equal to omega naught k cap, then omega naught can be given by 2 pi by 28 days inverse simply. So we can write the velocity of any point on Earth or any point of the ocean as omega cross r, which will simply be given in terms of I and j like this. We assume the density of liquid to be constant, the equation of continuity reduces to delta dot V is equals to 0. Now the F bar wrote down in Euler's equation, which is the force per unit mass. This can be simply given by the gravitational force, net gravitational force due to Earth and Moon, gravitational force or like simply the gravitational field. These were discussed by Ahana previously. Now we know that velocity of any point is given by omega cross r. Now we can simply from this calculate v dot del v and del v by del t. If we put these in Euler's equation, then we get the second equation as written on the screen. From the diagram, we can say that Re is equal to Rp plus d small d and Rm is equal to Rp minus d capital D. These were given in the first diagram. So these are very simple equations. And on putting these values in the Euler's equation, we get delta P by rho as which is given in the last equation. So now integrating the equation, we get the value of P by rho as this. Now the equation of the surface can be founded by the condition P is equal to constant. And after this, if we use the polar coordinates, then the equation of the surface will reduce to the last term, which you can see on the screen. In this way, we can get the equation of the surface during tides. That's all from my side. Now over to Bhavin. Thank you.
Hello, sir. My name is Bhavesh Sharma, and my work is to conclude our project. After acknowledging the topic, diving into some books, scanning research papers, and surfing the internet, we all got to know that the simplicity of these words doesn't matches with the complexity of its fluid mechanics behind it. Our experience with this project was very informative, where we learned about the theory of the topic, key role it plays on our daily life, and corresponding advancement by humans. Practically, we also learned teamwork and how a big topic can be learned it by breaking it into chunks. All the members as a team worked hard to gather maximum information and to summarize all possible information in a presentable way. Overall, we all feel that choosing and learning such common but important topic was a wise decision. Thank you.